Okay, here we have the second checkpoint of our chapter, and we will see some additional operations about cloud masking and pixel-based compositing. So this time, let's start by running the code immediately, as here we have some objects that were calculated also in the previous script, in the previous checkpoint. So we have the Landsat-8 composite, the composite from which cloudy images were removed, and the composite in which cloudy images were removed and clouds and remaining clouds were masked out. So this is the same code as before. Also this, here we have the function for masking out clouds. And indeed, here we had the end of the previous checkpoint. In this new code, the first thing that we are doing is to define a new image collection. The name of this image collection is Landsat-7. And again, it is from Landsat collections 2. As before, we are defining the apply scale factor function that is designed to be applied over an image and that can thus be mapped over an image collection. Then we are filtering our Landsat-7 collection. We are filtering it by bounds. We are filtering it using the dates we defined before. We are then removing cloudy images, so picking just the images in which the cloud cover property is smaller than 50%. And then we are applying over this function, over this image collection, we are mapping over this image collection the function that is needed to mask out clouds. That is the function that we defined in the previous checkpoint and also at the beginning of this one. And then finally, we are applying the scale factor function. We are mapping over this image collection the apply scale factors function. And then we are creating a composite just as before. We are calculating the median, and then we are clipping the image over the study area. I forgot to mention this code so far. So this is a code that is just needed to clip the image over the study area, so Colombia country. An important thing is that you can clip images, but you cannot clip image collections. So you can apply this code just at this step. So just once you have obtained an image from an image collection, in this case, the median from the Landsat-7 image collection. And then, as before, we are applying, we are adding the map adding the image to the map. And here we have the Landsat-7 composite masket, that is this one. So in this case, you are seeing a result that is very similar to that obtained using Landsat-8, because it is basically, we perform basically the same operations. We are just using Landsat-7 instead of Landsat-8. Yeah, but we have both Landsat-7 and Landsat-8 that are acquiring images over our period of interest, over our study period. So the idea is that we have to merge those images collection and use both of them to obtain a better composite. Here we have to rename the bands so that they have the same names in both images collection. There are some subtle differences in the number of bands and in the name of bands between Landsat-7 and Landsat-8. So this is the reason why this function is needed. The name of this function we decided to use is rename indeed. And we can map this function over the Landsat-7 image collection. So now we can merge our images collection. So we have the Landsat-7 image collection and the Landsat-8 image collection, from which we select just the bands that match the names of the bands of the Landsat-8 image collection over which we have applied their name function. And after that, we are just doing this operation that is actually a different operation than the previous one. This operation is just turning the images values into float. Probably because some of them were integers, some of them were floats, and so you have to perform this operation to don't get errors. The errors that you normally get when you don't do this is something like this image requires specific cast, something like that. Okay, so here we are printing the merged collections, and you can see that this time you have about 800 elements. That is about double of the image collection constructed using just Landsat-8 images. And we can, just as before, calculate the median, clip the image over the study area, and adding the image to the layer. And this is the new image that is appearing there. Just one moment more, as you can see from here. Okay, so the image is there, and as you can see, the amount of white pixels consistently decreased. We got a quite good composites. Again, you have to remember that this is a very cloudy regions, and so the region in which it is more challenging to obtain cloud-free composites. But so far, using simple operations, we already got a good composite. One of the limitations of this kind of composites is that you are calculating the median over a lot of images, and so that the main limitation is that the relationship between bands values in each image is not preserved. So when you are using those kind of images for calculating indices, this can imply some issues. Another issue of this kind of composites, so I mean the composites that you are constructing by averaging a lot of images or calculating the median over a lot of images. An additional issue is that you don't have the date for each pixel, so you have no idea about the day in which a pixel, so in which the image from which the pixel came from was acquired. One of the algorithms that try to solve this issue is the best available pixel, and is something that we can see in the next checkpoint.